Hello friends, this is a session on mixture and alligation, which is a very frequently used topic of mental ability, and it is also used in maths. So let us first of all understand the concept of mixture and alligation. First of all, what do we understand by mixture? So when two or more ingredients are mixed together in some quantity, we get a mixture. So very simple definition of mixture. Now, when we are mixing two or more quantities, their proportion in which they are mixed is normally expressed in ratio or percentage. So if we have two ingredients A and B which are mixed together, then we can say that A and B are mixed in a proportion of 3:5. So this is how we can express a mixture, or we could say that A is 60% and B is 40% in the mixture. So obviously I have not used 3:5 in this percentage terms, but I am just saying that we can either express the quantity of the two ingredients or more ingredients in as ratio, or we can express that in percentage. Now what do we mean by alligation? The English word alligation means action of attaching or linking. But what does that mean as regards the mixture? It's a rule that enables us to find the ratio in which two or more ingredients are mixed together, where we know the price or strength of these two or more ingredients. So this alligation actually gives us the rule that will enable us to find the ratio in which they are mixed together to get the mixture of desired price or strength. Now we are going to understand what do we mean by a desired price or strength, but just to get an idea, supposing we are mixing water in milk. This obviously means that the milk is diluted, right? So we can say that the strength of milk is not that of pure milk anymore. So now this alligation is going to, it's a rule that will enable us to find the ratio in which these two are mixed, right? So we are going to see now in the session what is that rule and how do we use that. So now the rule of alligation says that when different quantities of the same or different things of varying values are mixed together to get a mixture of mean value, then the ratio of their quantities are inversely proportional to the difference in their value from the mean value. Now, first of all, we'll understand what each and every word in this sentence says. When different quantities of the same or different things. Why same or different? Say for example, we are mixing rice variety 1 and rice variety 2. We are mixing these two things together. Now this is mixing of different quantities of the same thing. But we could, as we said in the previous example, we could be mixing milk and water. Now this is an example of mixing two different things. So when different quantities of the same or different things of varying values. Now why are we saying rice variety 1 and rice variety 2? Their values may be different. One of them may be 100 rupees per kg, the other may be 200 rupees per kg. So their values are different and these are mixed together to get a mixture of mean value, right? So obviously if we are mixing these two rice, one being 100 rupees per kg and the other being 200 per kg, we are going to get a mixture rice which will have a different price, which will be the mean of these two, depending upon the quantities in which they are mixed. So this rule of alligation, now let's read it again. According to this rule, when different quantities of the same or different things of varying values are mixed together to get a mixture of mean value, then their ratio of their quantities are inversely proportional to the difference of their value from the mean value. Now, let's understand what does it mathematically convert to. So it says quantity of first item divided by quantity of second item. As per the rule of alligation, we said that this ratio of their quantities are inversely proportional to the difference in their value from the mean value. So we'll say price of second minus mean value divided by mean value minus price of first, assuming that the price of second is more than the mean value and price of first item is less than the mean value. Now let me explain this. So first thing, we are clear that the rule of alligation suggested that the ratio is inversely proportional to their difference, to the difference of their value from the mean value. So we are saying quantity of first item inversely proportional means this mean value minus the price of list of the first is coming in the denominator. So this is showing that inverse proportionality, and we are saying inversely proportional to the difference in their value from the mean value. So that is why we are taking this difference. Now why are we taking? We have to see, when we are mixing a rice of 100 per kg with 200 per kg, the very obvious thing is that the mean value will be of the mixture rice will be somewhere between 100 to 200. So that means that the mean value will be greater than the lesser one, and it will be smaller than the higher one. So this is what we are saying. We have assumed that the second is higher than the mean and the first is lesser than mean. We could also see if in some cases it comes out to be other. So if we write first item to be 200 per kg and the second item to be 100 per kg, we'll just change this relation. We'll make it, in this place we'll make it mean value minus the price of second, and in the denominator it will become price of first minus mean value. So depending upon what is the relation between the mean value and the price. So this is what is going to give us the ratio of the quantity of the two items which are mixed together. So this is what the rule of alligation suggests. Now let's put it more simply to understand how does it work. We will show it pictorially now. Now if we say this is the price of the first item, let's call it P1, and this is price of second item, let's call it P2. When these two are mixed together, we get a mixture whose price is now PM, which is the mean price. Right? So we say P2 minus PM we draw here, and going on this side we get M minus P1. And again we are assuming that P2 is greater than M and M is greater than P1. Right? So now this picture shows that quantity, this is just a pictorial representation to help quantity of P1 divided by quantity of P2 is equal to P2 minus M divided by M minus P1. So this is how we put it pictorially so that it is easy to map it. So quantity of P1 divided by quantity of P2 is equal to P2 minus M by M minus P1. So just, the way it is shown, we just mapping it into this ratio. So using this formula, we can find out if we are given the mean values and the price of the first item and the second item, we can find out the ratio in which the two should be mixed or the two are mixed. So now we are going to see how do we use it. Where is this concept used? Okay, so first of all, it is used in mental ability questions. And these mental ability questions are all real life scenarios where we need to mix a couple of things in a proportion to formulate a mixture. There we need to first of all find out what is the mean price that should come out. So this is where we are going to use. Now simple problems where two things are mixed to get a mixture, right? We know in the real life scenarios two things are mixed. So now we need to find out the mean price. So we can use it for this also. So one application is definitely where we know the mean price, where we know the price of the first item and the second item, and we can find out the quantity in which the two are mixed. The second is we know we mix two things in a particular given proportion and then we find out what is the mean price of it, right? Then we also deal with problems based on impurities. So the example that we talked about where water is mixed with milk, that kind of concept, this mixture and alligation concept will be used to find out how much is the impurity. If we know the pricing, if we know the other things are provided to us, we can find out what kind of impurities, what proportion of impurities are there. Now, the important thing to understand is that mixture problems can be solved in a regular way also, but regular method is definitely more time consuming approach. So this is using it with alligation method makes it much faster. So this is a faster approach. So when we are talking about solving mental ability question in the entrance exams or other competitive exams, that we need a faster approach to solve these kind of a problem. So this is a much better and faster approach to solve these kind of problems. And this alligation rule is also used to solve problems like profit and loss, simple interest, compound interest, percentage also. So these kind of problems are also solved using the alligation method. So the most important thing here is that this concept is a faster concept of solving these problems. These problems can definitely be solved in a regular method, the way we solve different profit and loss and simple interest problems and other problems. We can solve them here using alligation method in a faster way. So now we will take an example. understand what we are talking about. We are taking two varieties of rice. So one variety is costing 20 per kg and the other variety is costing 40 per kg. Right, so we mix these two and we get rice worth, this is the mixture rice, worth 24 per kg. Now we need to find out the ratio in which variety 1 and variety 2 are mixed. So let's draw that and then understand how do we do it. So we are saying variety 1 20 and variety 2 costing 40 and we get the mixture costing us 24. So this is the mean value. So if we write P2 minus M here, we get 16, and if we get mean minus P1, we get 4 here. So the ratio, so this is variety 1, this is variety 2. So ratio of V1 to V2 will be given by 16 by 4. So which comes out to be 4:1. So this is the ratio in which we will mix the two varieties, which means 20 per kg will be 4/5 of the mixture and 40 per kg will be 1/5 of the mixture. Variety 1 will be 4/5 of the mixture and variety 2 will be 1/5 of the mixture to give us the mixture rice, which has a cost of 24 per kg. So now let's look at the solution of this question. So we'll just put out the statement again. Rice varieties 20 per kg and 40 per kg mixed to get rice 24 per kg. We need to find out the ratio in which the two varieties are mixed to get this resultant variety. So now let us take X kg of V1 variety and Y kg of V2 variety. What is the total cost? Total cost is 20 into X, because X per kg is costing us 20 per kg and Y is costing us 40 per kg. So we are saying 20X plus 40Y will be the total cost when we are mixing X kg of V1 and Y kg of V2. And what is the total weight of the mixture? This will be X plus Y kg. So what is the cost per kg? This can be given as 20X plus 40Y divided by X plus Y, and this is given to be 24, right? We are given this value as 24 per kg. So we can cross multiply. We get 20X plus 40Y is equal to 24X plus 24Y, or we get 4X is equal to 16Y. This implies X by Y is equal to 16 by 4, which is 4:1, right? So we get the same answer, and this is a standard approach of solving the mixture problem. So it is not that the alligation is the only method of solving it. Alligation is just a faster approach to solving these type of questions, right? So standard approach versus alligation method to solve a given problem. Now let's look at another usage of this concept, removal by equal amount. What do we mean by that? Let us understand. Now we have a container which contains X liter of milk. Now from this, Y liter is taken out and the same amount of water is added. Right? So what will be the ratio of milk in mixture? Now this becomes a mixture. Initially it was pure milk. Now it becomes mixture. Now what is the proportion? How much milk do we have? We have X minus Y liter of milk, because we had taken out Y from this and we mixed that much of water in it. So the total quantity remains X. So this is the proportion of milk in the mixture. Now again, this is step 1. Now if we again take out Y liter from mixture and add same amount of water. Now what will happen? Milk. How much milk will be remaining? Now we have, initially we had X minus Y milk, out of which X minus Y by X into Y is again taken out. Right? So this will be the remaining milk. Right? Initially we were having the complete mixture, complete milk. Then we got this much of milk, and now from this much of milk we've again taken out Y of this much milk. So we are remaining with X minus Y is the total one, minus X minus Y is the initial milk in this second step, so minus X minus Y by X into Y. Now what is the ratio of milk? This will be given by X minus Y minus X minus Y into Y by X, divide by the total quantity, which is again nothing but X. So if we simplify this, we get X minus Y by X whole square. Right? So this is now the ratio. So if we, in the third step, we again take out Y liter from the mixture and add water, we will see, doing the same kind of calculation again, we will see it becomes X minus Y by X whole cube. So this is again ratio of milk. So this, if we repeat this process of removal by equal amounts, then the ratio of milk continues to reduce in the similar manner. So the ratio is given by X minus Y divided by X whole raised to power n if the process is repeated n times. So now this is the formula that we can remember, which is very commonly used. So instead of doing it again and again and doing this calculation repeatedly, we can simply use this formula to say that if the same process of taking out equal amounts is repeated n times, then the ratio of the original quantity, which is milk in this case, original ingredient which is milk in this case, will be X minus Y by X whole raised to the power n. So friends, you can visit us at our Cool Smart Learning website and subscribe to our YouTube channel to get more updates on the new sessions. Thank you.